Good morning guys, Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Right? In the last session, we successfully discussed about the concept of piezoelectric transducer, right? How it's working, right? So what is the construction phenomena? How the force which is converted to the voltage? So what is the voltage equation that we discussed? Right? I just want to give a brief rewind of all the things related to piezoelectric transducer that we discussed in the last session. Right? So what is piezoelectric transducer? Right? So the name itself, what is piezoelectric? Piezo means squeeze. Electric means a charge will be accumulated. When squeeze a crystal, when you apply a force on the crystal, so there will be a charge accumulated. Right? So how it will be meant if it is a crystal? If it is a charge, when you apply a force, so there will be a charge will accumulated. If it is a crystal, right, like a quartz crystal, Rachel short, these are the crystals that we are going to use in this type of piezoelectric transducer. Right? So what is a piezoelectric means? When squeeze something, so there will be a charge accumulated. So when you apply a force, so definitely there will be a charge around the crystal. So whatever the charge, there will be a current will flow. So these current can be calibrated in terms of moving coil meter, voltmeter, right? So whatever the voltage that you are getting, which is analogous to the force that you are applying, force, strain, pressure, whatever it may be, right? So your non-electrical quantity, force, pressure, strain, which is converted to voltage. Right? This is like a piezoelectric transducer, how it's working and all these things, right? So applied force always not a static force. If it is a static force, there is no charge movement, there is no current, there is no voltage induced in a coil. Right? So always whatever the force that you applied on a crystal must be a dynamic force, not the static force. If you apply a static force, the induced voltage is equal to 0. That's very, very important question. Right? So how much charge? So whatever the charge which is directly proportional to force. So that is not, if you remove this dF. So D is nothing but Q by F. Where D we can call it as a charge sensitivity. It's not output by input now. So change in output by change in input. So that is called charge sensitivity. Coulomb first, Newtons. Right? So this charge sensitivity must be depends on the direction of a force. If you apply a force in this direction, there will be a charge sensitivity in this direction. In this direction, we will get difference of charge sensitivity. So overall charge sensitivity of the transducer is given by square root of D11 square, D22 square, D33 square, and so on. Whatever it may be. If it is 11, we will take it as D11. If it is 122, we will take it as 22. Whatever it may be, right? So this is the overall charge sensitivity on a crystal, piezoelectric transducer, right? So how much charge, how much voltage that you are generated, it depends on how much force that you apply. So what is the equation for this? For this, the voltage equation we derived in a last session. So what is the voltage equation? E is equal to GPT. Very, very important equation. Where G is nothing but voltage sensitivity, right? P is nothing but pressure, how much pressure that you applied. T is nothing but thickness of the crystal. Alright, so this is nothing but thickness of the crystal. E is nothing but developed voltage. Right, this is very, very important equation. How much voltage that you are getting from a piezoelectric transducer. That means whatever the E is directly proportional to the pressure that you applied. Right, it's a linear scale. Right. So what is the equation for G? G is nothing but voltage sensitivity. What is the equation? What is the formula? D by epsilon. So where D is nothing but distance. D is nothing but what you called charge sensitivity by epsilon naught epsilon naught, relative permeability, right? Either zero free space or relative permeability, whatever it may be, right? So this is the equation that you are getting, that we derive in our last session regarding piezoelectric transducer. Right? I hope it's clear about all these things regarding piezoelectric transducer. Now today we are going to discuss about two concepts, that is called photodiode and synchro transducer. Right? Not that much concept related to synchro, because you know everything about synchro. Right? I don't want to explain more about synchro, because you did your experiment in your last session also, last year also. So I don't want to take more time on that synchro concept. Right? So with this session we will finish our second unit concepts, all the transducer concepts. Right? So first we will discuss about photodiode. Right? What is a photodiode? It's nothing but a diode. Right? Diode is nothing but it is nothing but p-n junction diode. p-n junction diode. So we can use this p-n junction diode in different ways. So one of the way is nothing but photodiode. The name itself, photodiode means, photo means light. How the light energy is converted to electrical energy. Right? So photodiode, the name itself indicates, photo means light, how the light energy which is converted to voltage. So we can call it as a transducer. This is nothing but a photodiode, is nothing but a transducer. So it is active transducer or passive transducer. It doesn't require any external supply. So that is called active transducer. Alright. So it's nothing but a normal diode. The symbol is like this. This is anode. This is cathode. Right? So this we can call it as a light. When light or photon focused on the diode, so there will be electrical energy is generated. So this is a symbol of a photodiode. See, photodiode is nothing but p-n junction diode. Right? So the name itself indicates, photodiode means where light energy which is converted to electrical energy. Alright, so it's nothing but a transducer also. It's an active transducer. This is a symbol of a photodiode. It's also like a two junctions, P junction and N junction, and anode and cathode. Here one more thing is a photons or light hits the diode, there will be electrical energy is generated. Right? So we can call the photodiode work in reverse bias condition. Reverse bias condition. Right, the photodiode will work on a reverse bias condition. We'll see when forward bias applied, what will happen across a p-n junction diode when a light hits. We'll see all these things. So this is the basic things what we need to know in photodiode. So photodiode is nothing but a p-n junction diode. The light energy which is converted to electrical energy. Right? It's like a transducer which is light energy non-electrical quantity which is converted to electrical quantity. It's nothing but an active transducer because we don't have any external supply for this. And after that, the symbol of photodiode is like this. It consists of anode and cathode, and light hits the diode, definitely there will be electrical energy generated. Right? So this type of photodiode will work on a condition of a reverse bias p-n junction diode. This photodiode will work. Right? We will see the construction, how it will work. Alright. So what is a PN junction? Now we will see how the photodiode will work, right? How the photodiode means how the light energy which is converted to electrical energy, right? You know that photodiode is nothing but PN junction diode which is connected to the reverse biased condition. We'll see. Reverse bias means P-type material which is connected to the negative, N-type material which is connected to the positive. Alright, so this is a P-type and this is a N-type. Alright, so P-type holes is a majority carriers. Right, and electrons is a minority carriers, small little bit electrons, right? In N types, electrons is a minority carriers, right? And holes is a minority carriers, right? So these holes, if you connect it in a reverse bias, so this we can call it as a depletion layer. You know about a depletion layer. So it's nothing but we don't have any free electrons. It will make a neutral atom. So how it will make means you know about everything, right? When P-type material with N-type material will club, what happened? If these are the holes, these are the electrons. Right? When you club it together, what happened? These electrons will move here and fill with the hole because this is a negative charge and this is a positive charge. So this will fill, this will fill, this will fill. Like this, in this region, the neutral molecule will present. For suppose if it is a silicon atom, before joining, you will have a hole and these are the electrons. Here, N-type you have electron. You just electron fill with this one, it will make a neutral atom. That means outermost 4 electrons filled. Right, it will make a neutral atom. That means that doesn't have any free electrons to move. There is no current. There is no current. That means here you'll get the positive ion and here you'll get the negative ion. Right. So that is called a depletion layer. If you're forming a depletion layer means you are generating your neutral atom. So you are forming a neutral atom. So here you will get the poles reflected here, positive ions. Here you will get the negative ions. Right? So but in the depletion layer, what you have, the positive ion, negative ion. In this you have a force, electric force is there from positive to negative. Only force is present. There is no free electrons, there is no charge. But the force is there. That's, you know. See, now when a light hits that depletion layer, whatever the light, right? So if this light which is having energy, right? So energy is equal to H into F. If it is 1 photon, that is called E is equal to 1 HF. If it is 2 photon, E is equal to 2 HF. If it is a 3 photons, E is equal to 3 HF. Alright, now whatever the depletion layer, in a reverse bias condition, whatever the current is due to the minority charge carriers, right? The current is very less value. How the depletion, how the current is nothing but like this. So whatever the current is due to minority charge carriers. Right? Now you are hitting your light on a depletion layer. See what happened. Now in a depletion layer you have a neutral molecule. Right? Neutral molecule means whatever the silicon outermost you will fill with 4 electrons. Right? It's a neutral molecule. Right? Neutral molecule, that means neutral atom. So it doesn't have any free electrons to move. ఎప్పుడైతే photon hits the depletion layer, hits this atom, so what happened? From this neutral atom, 1 electron is going to be moved. So this electron will move, 1 hole is created. రైట్, సీ ద మ్యాజిక్. ఎప్పుడైతే ఆ ఫోర్స్ తోటి ఫోటాన్ న్యూట్రల్ ఆటమ్ డిప్లీషన్ లేయర్లో ఉన్న న్యూట్రల్ ఆటమ్ని హిట్ చేస్తుందో ఏమవుతుంది, ఒక ఎలక్ట్రాన్ వెళ్ళిపోతుంది. సో దెన్ దేర్ విల్ బి అ హోల్ క్రియేటెడ్. లైక్ రైట్, సో హియర్ a negative charge and holes will create a positive charge. See the magic. Here you will know two things, right? The first thing is the electron is out from the neutral atom, so these electron will again feel that positive, he again attract the positive. One thing, see, in a depletion layer you have a force, right? What's the direction of a force? If it is a plus, if it is a minus, so this is the direction of a force, right? So this force on an electron also, this force on a positive, right? Electron also, whatever the force that you are having in a depletion layer, it will be on the electron or it will be on the positive ion. So what happened, this positive will attract the negative, this electron will attract the positive, right? See, now with this force acting on a depletion layer, so whatever the electron and holes from a neutral atom, these electrons attract the positive. So this whatever the electron hole form in the, right? So whatever the electron will attract the positive and it will move like this. Whatever the hole, it attract the negative, it will move like this. That means they won't attract each other in a depletion layer. If attract each other, there is no it again creates a neutral atom. That means whatever the electron will move n side, whatever the holes will move the p side. See, whatever the electrons moves on the n side, that means it is increasing the charge carriers, right? In a p type, it is also increasing the charge carriers, right? I hope it's clear. Now it's increasing the charge carriers means whatever the current that you are getting, it should be increases, right? Why the current is increases? That is not a single light. The light is nothing but number of photons. When number of photons hits that neutral molecule, again electron and hole created. So these electron will attract the positive, these hole attract the negative, right? Again electron will move to the n type, holes will move to the p side. So then what happened? Definitely the number of charge carriers in n type increases, number of charge carriers in p type increases. So then what happened? The current is increasing. That means whatever the current is going to be calibrated in terms of voltage, whatever the voltage which is directly proportional to the light that you applied. I hope it's clear. So whatever the light that you applied, it will increases the number of charge carriers. So whatever the, per suppose before the light, whatever the charge carrier is having a 15 microamperes, right? So when you apply a light, whatever the current is 25 microamperes, right? So 25 microamps, it can be calibrated by the voltmeter, you will get the 50 volts, right? How you are getting the 50 volts, which is analogous to the whatever the light that you apply, right? So whatever the light which is converted to the voltage. So this is actually the mechanism how the photodiode is working, right? Whenever the light hits the depletion layer neutral molecule, which is a divided electron on hole pairs, when electron, due to the force in a depletion layer, electron will attract the positive, holes will attract the negative. So they can, then what happen? N type electrons increases, p type holes increase, number of charge carriers increases. So that means the electron which coming out from the neutral atom, due to the force, the electrons moves to the n-type material and holes moves to the p-type material. So then what happened? The charge carriers under n-type electrons will increases, the charge carriers under p-type holes will increases. So thereby charging current increases. So whatever the current which is standardized, which is find out by the moving coil meter, how much voltage is developed. So whatever the voltage, that is analogous to the whatever the light that you applied across a depletion region. So this is how the photodiodes are working and all these things. I hope it's clear. So this is a working phenomena, right? This is a working of photodiode, that's it. Photodiode. But similarly, the PV cells, nothing but a PV cells, right? when solar energy, solar is nothing but photons. When photon hits, definitely the whole electron hole recombination will happen. So with that there will be a current will flow. So similar things that will get in a photovoltaic cell, PV cell. Alright, I hope it's clear. Alright. So this is about photodiode. What we discussed means photodiode means, so it's nothing but a PN junction diode which is connected in a reverse bias. When photon hits at or PN junction diode, whatever the light energy which is connected to, which is converted to electrical energy. It's like it's the symbol that we discussed and how the working of a photodiode that we discussed. Alright. Now we'll discuss about the synchros. So I don't want to discuss in detail about synchros, right? How the synchro, we can call it as a transducer. Right. So what is a synchro? Synchro transducer means whatever the angular position of a rotor which is converted to electrical energy. Synchro means which consists of a transmitter and a receiver. So whatever the angular displacement which is converted to voltage, that is a synchro. It's nothing but error detector that you can use in a control systems, right? You know everything about this one. Alright. Here the synchro is nothing but a sensor, so which convert angular displacement, angular position of a rotor, into voltage. Right? It's nothing but a transducer. Alright, so it's a passive transducer. It's require a power supply. It's require auxiliary supply for this operation of a transducer. So how it will work means, see, nothing is there. You have a stator, right? So which is having a rotor. Right? The rotor is excited by the AC supply. Alright, so rotor is excited by the AC supply. So then the stator, which is having a 3-phase windings, right? Right? In the stator you will get the voltage. So we have a voltmeters over here. Alright. So this is the function, this is a schematic diagram for a synchro as a transducer. It's nothing but a rotor, it's a stator. Alright, so whenever the rotor is excited, the rotor starts rotating magnetic field will be developed. These magnetic field enter into the stator conductor, so there will be a voltage generated. So this rotor which is connected to the shaft, alright, the shaft positions, so first you will make that rotor in 1 degree position, then find out the voltage, right? So another position, then find out the voltage. So likewise, whatever the change in position, you are getting the voltage. So that is the operation, nothing is there, right? So whatever the voltage that you are getting is equal to cos of position, we can call it as a theta, sine omega t. Omega is nothing but 2 pi f angular frequency, t is nothing but time period. So E2 is equal to cos of position plus 120 degrees sine omega t. E3 is nothing but cos of theta plus 240 into sine omega t, where theta is nothing but angular position. Right? So if you are bearing an angular position of a rotor, definitely the EMF will be different. So that means whatever the angular position that you applied across the rotor, which is converted to the voltage. So it's like a sensor. It's like a synchro sensor. That is nothing but synchro transducer. I hope it's clear. So this is about a simple thing, how synchro transducer working and how the voltage you are getting by varying the position of a rotor. Right? So this is all about regarding a transducer concept, whole about a transducer concept. So with this we successfully completed our second unit related to transducer. So in this we discussed about that what is a transducer. Alright, so what is a transducer? After that, characteristics of a transducer. Alright, so choice of selection of transducer. Right, advantages of transducer. Right, so different types of a transducer. In that we successfully discussed about resistive transducer, inductive transducer, capacitive transducer, and some other important concepts of LVDT, right, strain gauge, and some active transducers. So we discussed about thermocouple, thermistor, right, so piezoelectric transducer, right. So after that we discussed about photodiode, then synchro transducer. So these are the things that we discussed in detail, no doubt about that from my side. Right, if you have any doubts regarding total unit, in the next session we discussed about the brief review of the whole unit that what we completed. Right, so with this we will be completed the unit 2, and day after another session will start digital voltmeter concept. I hope it's clear. Alright, thank you for now.